So we've discussed the users, and then it's appropriate to talk about another of three whales that Unix-like systems rest on: processes. We can get information about the processes by running the PS, process status command. In this case, we again see two worlds, two systems, System 5 and BSD. And what about GNU? As we can see, GNU PS supports both sets of options with some GNU-specific long options. By default, PS without options shows only processes started by me and connected to my current terminal line. To get the status for all processes, we must use PS-EF for System 5 and PS-AX, maybe without dash, for BSD. And we can get more information about the processes using the long options. PS-L for System 5 and maybe just L for BSD. What information about the processes can we see? User identifier. Effective user identifier. A process can have a different identifier than the user running the application, because as we will see later, this is a mechanism in Unix-like systems to change the identifier on the run of program. Process identifier, number representing the unique identifier of the process. Parent process identifier. Actually, we have a hierarchical system of processes, and each process has its own parent. We can see this hierarchy, for example, by such option set. Or just by command PS3. Priority of the process. Higher numbers means lower priority. But as we will discuss later, we cannot change the priority because this value is dynamically changed by the process scheduler. And we can only send recommendations to the scheduler using the nice parameter. Nice can be set with nice or renice commands. More information about priorities and nices you can find in Under the Hood process scheduler lecture. TTY, controlling TTY terminal, and command. And also very useful, especially if the system slows down, command top, which dynamically displays information about processes sorted accordingly by the use of system resources, memory and CPU time. Nice. Nice run a program with modified scheduling priority. Nice value, it's just an integer. The smallest number means the highest priority. Nice's range can be different on different systems, and you should look at the man nice on your system. In the case of Linux, nice value between -20 and 19. Only the super user can increase the priority. The normal user can just decrease the default, which can be seen by invoking the nice program with no arguments. For example, nice minus n19 means execution of the command with the lowest priority. This can be useful for reducing the activity of non-interactive applications. For example, such as the backup process, which can slow down the interactive response of the system. Very nice. Alter priority of running process by process identifier. In this case, you may not use -n option, just a nice number. For example, by this way. At the shell level, we can use the jobs mechanism. The easiest way to start off new background job is to use the ampersand symbol. Once the command is running, we can disconnect from the terminal line and pause it by pressing Ctrl Z. As we can see, the top in Xterm stopped now just because the Xterm application is stopped. We can see background and suspended jobs using the jobs command. In the first position of the jobs list, we see the job number. We can use this job number with a % sign in front of it a suspended task, we can switch it to the background execution mode by default, the current job. As we can see, the top running again. And we can reattach the background job to the terminal line by bringing it to the foreground. That we can interrupt the foreground job by pressing Ctrl+C. Xterm killed now. Another way to terminate a process is with the kill command. Also, you can kill the process by process ID number. But in some cases, kill does not work. For example, if the process is frozen. But even so, we can kill the process just because kill is actually sending a signal to the process. And we just have a choose a different signal. This is the list of signals. SIGTERM, generic signal used to cause program termination, default kill. SIGINT, program interrupt, by the interrupt key, usually Ctrl+C. SIG kill, immediate program termination, cannot be blocked, handled, or ignored. SIG hub terminal line is disconnected. Often used for daemons config reading just because daemons not connected to TTYs. SIG quit core dump process. Quit K, as we remember, usually Ctrl/. When you execute a Unix job in the background using ampersand or background command and log out from the session, your process will get killed. We can avoid this using no-hub command. No-hub running command immune to hang-ups with output to no-hub out. Another very useful program is the screen. It's a screen manager with VT100 ANSI terminal emulation, which supports multi-screen sessions with offline execution. In fact, you can run some long-running commands on multiple screen sessions, and after disconnection from this terminal line with your hands or after breaking, connecting, and then you can reconnect to this screen and you will see that all processes are still running. And another possibility of offline executing commands is later execution and scheduled commands. Add, batch, ATQ, ATRM, for queue, examine, and delete jobs for later execution. And for time-based job scheduler, we have the command cron tab, which maintain cron tab files for individual users.